so let's go ahead and look at this position graph. And like I said, if you haven't taken physics at all, you want to make sure that you look at that little intro graph. It talks about this here. Okay, so main thing we want to look at is what's going on this graph. Okay, so I want you to think about, we've got a particle, and in this class, all of our particles are going to be moving up and down or left and right, mostly just left and right. So I want you to think about what's happening in this graph, or what is happening with this particle here. Okay, so the particle is going to start at position 0. Okay, and I want you to think this is the x right here, so it's starting at 0. So if we put this to something we're more used to seeing, I'm not even going to put the y in there, because it's only going to be moving left and right. Okay, so let's say it starts here at 0. Okay, so it's moving, as for the first 2 seconds, it moved over to position 2. Okay, so it moved right here during the first 2 seconds. So what this graph is going to give us is how fast it did that. Okay, then it spent a second doing nothing. It just sat there. Now it's changing its direction because it was at 2 and it went back to -2. Okay, so it went back here. So now what you think, it's really just going like this, back and forth, back and forth. I'm putting it up here just so that you can see what's happening. Okay, now it sat there for a few seconds, and then it turned around again, and it went from -2 to about 1.5. So it's here, and it ends up about here. Okay, so that's what's happening in this graph, what that's telling us. All right? Okay, so we've got some vocabulary words that we have to look at. So we have, what's the displacement of the object? So let's look back here. And displacement wants just the change in position. It doesn't want to know how far did it go. Just where was it? Where did it end up versus where did it start? Okay, so again, I want you to focus on the notation that I'm going to say, well, I want its position at 12 minus its position at 0. And this is just a good habit for when these problems get really hard. You're going to just always be doing the same thing. Okay, so we said in our picture that it was at 1.5. Where did I put that? Okay, so it started here at 0 and it ended up at 1.5. Okay, so it was at 1.5 minus 0, and it's 1.5 units. Because we don't know how long those units are. I guess we could say meters, and sometimes we'll even say like it's 1.5 meters to the right. And when I mean to the right, that it is now ended up, it was here, and it ended up to the right of where it was. Okay, so again, this notation is going to be really important. Okay, what's the total distance traveled? Now, total distance wants to know, okay, this thing was going back and forth, back and forth. So we want the absolute value of all of these, because we're going to say, okay, like this is 2 to the right. We're going to say like this is +2, then it went -4, and then it went +3.5. So we're just thinking that it went 2, and I'll just say that, show it like that, because it went to the left for 4, and then it went to the right for 3.5. So 9.5. And we're going to say meters. Okay, and I got that from right there. Okay. All right, what was the average velocity? Okay, so average velocity, that's slope of the secant line. Okay, so average velocity, and we're going to write that with a V little bar on top. Okay, so average velocity, and let's look in our definitions over here. There it is. Okay, that's where it ended up, where it started, b minus a. It's just the slope. That's all it is. Okay, so we want to say, okay, it was during the first 3 seconds. So that's going to be s of 3 minus s of 0. Its position after 3 seconds minus its position at time 0 over 3 minus 0. Okay, well, after 3 seconds, let's see where it was. It was up here. It was at 2. Okay, at 0 seconds, oops, I'm sorry. After 3 seconds, it was up here. Okay, so it was at 2. It's 2 to the right. Okay, at 0 seconds, it was at 0. Okay, so the average velocity then is 2/3 meters per second. Okay, so again, meters per second. Okay, the velocity of the object at t equals 9. Now remember, if it just says velocity, that implies that we want instantaneous velocity. So we want the velocity at 9 seconds. And that is the derivative of the position function at 9 seconds. So now here we have to remember that, well, the derivative is the slope of the tangent line. And nice and convenient, these are all just linear. So the slope of the tangent line will be the same as the slope of the line. Okay, so at 9, I'm right here. So this line right here has a slope of, looks like it goes up 1.5 and it goes over 2. So I can say 1.5 over 2. I could write that as 3/2 over 2 over 1, which is just a complex fraction, times 1/2, which is going to be 3/4 of a meter per second. Okay, and that's its velocity. So well, I'm going to put something like that. Okay, and whenever we say velocity, we mean instantaneous velocity. Okay, when is the velocity undefined? So this is where we have to always be thinking about what are we finding. Okay, velocity, remember, slope of the tangent line, it's the derivative. And remember that you can't find derivative, you can't find a derivative at a sharp corner. Okay, so undefined at sharp corners. So the velocity would be undefined at t equals 2. Okay, we got a sharp corner right there. Got a sharp corner there. We got a sharp corner there. We got one there. There's one here. And I know that because these are lines, their limits are not going to be the same as I'm coming from the left and the right. There is one there. So at t equals 2, 3, 5, 7, 8, and 9. The velocity is undefined. Okay, now, did the object initially move to the right or to the left? So one thing that you want to do is you want to check the sign of velocity. So you want to be thinking velocity is the slope because it's the tangent. Okay, so the velocity, oops, I shouldn't write prime. Okay, velocity is positive here because the slope is positive. So if the velocity is greater than 0, it's going to be moving to the right. And we didn't need to know, I mean, we knew that kind of as we looked at that little graph, but I'm going to prove it. So that's how I prove it. So it started out moving to the right. Okay, how many times did the object change directions? Okay, well, that's the thing that we just looked at the very beginning. So we said it went here, then it went here, and then it went here. Okay, so anytime velocity changes sign, it changes direction. So velocity was positive here, then it was 0. That means it's just at a standstill. Velocity here is negative because the slope is negative. Velocity here is 0. Between here and here, velocity is greater than 0. Okay, so it changed sign 3 times. Okay, so we're going to say, how many times did it change directions? We'll say 3 times. And then we can say, okay, from 0 to 2, it moved to the right. And I guess maybe technically we changed directions 2 times. Well, I got to think about how I want to say that. Okay, from 3 to 5, it went to the left. And from 7 to 10, it went to the right. Okay, when was the object at rest? Well, it's at rest when the velocity equals 0. Okay, so that was between 2 and 3. And I am using interval notation here. 5 and 7, and 10 and 12. So you're always listing, anytime you're doing intervals, I want you to use interval notation. Okay, where was the object at t equals 4? Okay, so let's think about this. When t equals 4, and actually I'm showing in my notes, I want to change that to 5. Let's change that to 5. Okay, so at 5 seconds, let's think about what we did. We first moved 2 to the right, then we sat there, and then we moved 4 to the left. So we should be at -2. Okay, now let's see how we're going to describe that. So this, where was the object? This is displacement. Okay, so I want you to think. We're going to take s of 5 minus s of 0. Well, at time 5, it was at -2. At time 0, it was at 0. So its placement is 2 units, and actually we're going to say meters, left of the origin. Okay. And the last one here. Okay, what was the speed? So we want the absolute value of the velocity. When was that the greatest? Well, that would be when the slope was the greatest. So let's see. And it doesn't matter if it was positive or negative, because speed is the absolute value. Okay, so it's pretty steep right in here. Looks like that's going up 2 over 1, down 2 over 1 on this one. So looks like in here and in here. From t equals 3 to t equals 5, the velocity was -2. And from t equals 7 to t equals 8, the velocity was 2, which means that the speed on both of those was 2.